This is SpaceTime, Series 24, Episode 131, for broadcast on the 17th of November 2021. Coming up on SpaceTime, unlocking the secrets of star formation. The Lucy mission to the Trojan asteroids of Jupiter continues despite its crippled solar array, and China continues its campaign to launch more spy satellites. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Astronomers have discovered unusual structures in the western wall of the spectacular Carina Nebula. The findings, reported in the astrophysical journal Letters, show a series of long parallel ridges deep inside star-forming molecular gas and dust clouds. The ridges look like a remarkable, almost perfectly smooth wave, with fragments that appear to be in the process of being sheared off the cloud by a strong stellar wind. The structures are thought to be produced by a magnetic field. Astronomers also observed evidence of a jet of material being ejected from a newly formed star. The unprecedented observations were made using the adaptive optics capabilities of the 8.1-metre Gemini South Observatory in Chile. Adaptive optics uses actuators to constantly deform the telescope's primary mirror. This compensates for atmospheric turbulence and temperature layering differences. It's these effects in the atmosphere which make stars twinkle, which is great for romance, but not so good for astronomy, as it blurs the images. By using adaptive optics, astronomers had a tenfold improvement in the sharpness of their observations. The brilliant Carina Nebula, located in the southern skies, is a spectacular stellar nursery where gas and dust are condensing to form new stars. It's 500 times larger than the better-known Orion Nebula, making it an ideal candidate for investigating star formation. Star-forming regions are shrouded in gas and dust, but it's possible to see through these clouds by observing in infrared. Astronomers peered through the nebula's outer layers to reveal a huge wall of dust and gas glowing in intense ultraviolet light, heated by nearby massive young stars. The region was observed at the infrared wavelength of molecular hydrogen. Molecular hydrogen is the best way to trace the structures because they would otherwise be rendered invisible by dust blocking them in the optical and ultraviolet wavelengths of the Hubble Space Telescope. The new images are providing astronomers with their sharpest view yet of just how massive young stars affect their surroundings and influence how stars and planet formation proceeds. The study's lead author, Professor Patrick Hartigan from Rice University, says it's possible that the Sun and planets of our solar system were formed in exactly such an environment. He says if that's the case, then radiation and winds from any nearby massive stars would have affected the masses and atmospheres of the solar system's outer planets.
Gemini South is a large telescope. It is 8 meters in diameter, and it sits atop of a mountain in the Andes in Chile. And what this instrument does is it allows you to get very, very sharp images of objects, because what it does, it actually distorts the shape of the mirror, so that compensates for any sort of shimmering in the Earth's atmosphere. And the other reason for going down there where you have to take the images in the southern hemisphere is that there are some parts of the sky that just are never visible from the north. Well, Carina is a very interesting area of star formation because it's probably the nearest star-forming region to us that has really, really massive stars. And that's very important because what the massive stars do, is they emit a lot of radiation, and that can actually affect the surrounding cloud out of which other stars are forming. These images really show clearly for the first time how star formation proceeds in regions that have massive stars, and an awful lot of stars form in those kind of regions. Ultimately, this is the story of creation, because what you're doing is you're looking at regions that are actually forming new stars and planets. So a couple million years from now, there will be new stars and planets there that don't exist now. And those will go through their lives and will be shining long after the Earth and the Sun have disappeared. In the meantime, the Sun will have thrown off its outer layers back into the interstellar medium, and then those provide new gases for new clouds, which then in the future form new stars. So there's this really large cycle of stellar life that is occurring. And what we're doing here is we're actually seeing into the stellar nurseries in very high detail through the dust, which is what the infrared light gives you. And you can really begin to see what's happening right at the beginning when stars and planets are forming.
That's Patrick Hartigan from Rice University. And this is SpaceTime. Still to come. Mission managers still trying to work out how to fix a jammed solar array on the Lucy spacecraft. And China launches 3 more spy satellites as it continues to build up its orbital armada. All that and more still to come on SpaceTime. NASA mission managers are still trying to work out how to fix a jammed solar array on the Lucy spacecraft. Lucy is on a 12-year mission to study Jupiter's Trojan asteroids. The circular solar panel, one of 2 on the spacecraft, failed to fully unfurl and lock into place shortly after launch. Based on its electrical output, NASA believes the solar panel is somewhere between 75 and 95% extended, with a lanyard simply holding it in place. The mission's lead scientist, Hal Leveson from the Southwest Research Institute in San Antonio, Texas, says the combined power of both solar panels is keeping the spacecraft healthy and functioning. He says the problem isn't affecting spacecraft performance or the power supply to onboard instruments. However, it's still far too early to determine longer-range implications for the mission. Lucy is now well over 8 million kilometers away. But that still means it's getting fairly intense solar radiation from the Sun charging its panels. Once it's further away, say where Jupiter is, the solar radiation will be far less intense. Scientists say they'll make another attempt to try and open the panel in a few weeks' time. We'll keep you informed. This is SpaceTime. Still to come. China launches 3 more reconnaissance satellites, and ticket sales flying for Virgin Galactic, with more than 700 people now booked for the ride. All that and more still to come on SpaceTime. China has launched 3 more reconnaissance satellites. The latest missions both flew from the Jiuquan Satellite Launch Center in northwestern China. The first to fly was a Xiaoling 1 Golfeng 02F high-resolution optical remote sensing satellite. It was launched aboard a Kuaizhou 1A rocket. It was the 12th flight for this 20-meter tall solid-fueled launch vehicle. The successful flight was followed days later by the launch of a Long March 2C rocket, also from Jiuquan, this one carrying 2 Yaogan 3202 spacecraft. Now, Beijing described the Yaogan 32 as remote sensing satellites for the Ministry of Agriculture, keeping an eye on things like crop yields and forestry. In reality, the Yaogan 3202 are signals intelligence gathering satellites designed to spy on the communications of other countries. Yaogan 32 spacecraft are placed into 700-kilometer high sun-synchronous orbits. This flight was the 394th mission for the Long March series rocket. Since 2016, Beijing has launched more than 143 Earth observation and reconnaissance satellites, including 32 Golfeng satellites and some 86 Yaogan spy satellites. This is SpaceTime. Still to come. Tickets flying for Virgin Galactic, with more than 700 people now booked to ride to the edge of space. And later in the science report, a new study warns that leaving the toilet lid open after flushing increases the risk for the spread of infection. All that and more still to come on SpaceTime. It's been revealed that Virgin Galactic now has around 700 people booked for its rocket plane flights to the edge of space. Reports claim 100 tickets alone have been sold since the company's founder Richard Branson took his trip earlier this year. And the price has gone up too, from the original $200,000 to $250,000 per seat up to around $450,000 for a ticket today. Virgin Galactic was expecting to be flying commercial passengers by now, but missions are on hold after tests revealed some concerns about the materials being used in the spacecraft. In fact, Virgin was forced to postpone a planned suborbital test flight for members of the Italian Air Force because of the issue. The company now hopes to begin commercial flights later next year. Meanwhile, Virgin Galactic's main competitor on the space tourism front, Blue Origin, is also expecting to commence commercial operations soon. And of course, its new Shepard rocket has one big advantage over Virgin Galactic's Spaceship 2. That is, it actually passes beyond the Kármán line, the 100-kilometre altitude which marks the internationally recognised official start of space. New Shepard also launches like a rocket from a conventional launch pad. Virgin Galactic's Spaceship 2 rocket plane, on the other hand, is drop-launched from an aircraft at 50,000 feet. It then fires up its onboard rocket engine and shoots to an altitude of around 86 kilometres. That's above the 80-kilometre mark which America uses to classify people as astronauts, but still well below the internationally recognised boundary. This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with a science report. A new study warns that leaving the toilet lid open after flushing, uncovered trash cans and defective plumbing drains are all playing a significant role in spreading infections in public restrooms. The findings, reported in the journal Science and the Total Environment, are based on 38 different studies from 13 countries looking at the risks of bacterial and viral transmission in public bathrooms. The results showed widespread evidence of contaminated surfaces as a cause of fecal-oral transmission in public toilets in restaurants, workplaces, commercial premises, and universities. But there was no documented instances of airborne-related infectious disease transmission. Still, the authors found that bioaerosols can potentially be transmitted throughout a multi-story building by defective plumbing, and that leaving toilet lids open after flushing can disperse contaminated droplets beyond a metre. Researchers also found that uncovered trash cans in public bathrooms are also a risk, especially if they're located under or close to electric hand dryers. Iran has boasted that it's almost doubled its stockpile of enriched uranium. Tehran says it now has more than 210 kilograms of uranium enriched to 20% and 25 kilos enriched to 60%. The Islamic Republic has progressively abandoned its commitments to its 2015 Vienna Nuclear Non-Proliferation Treaty. The 2015 agreement with Britain, China, Russia, France, Germany and the United States offered Iran sanctions relief in return for abandoning its development of nuclear weapons and the missiles needed to deliver them. But the Islamic Republic has repeatedly broken its agreements, including the development of nuclear-capable missiles under the cover of a thinly disguised space program, refusing access to International Atomic Energy Agency weapons inspectors, and refusing to disclose the location of key nuclear weapons components in its possession. The International Atomic Energy Agency says Iran started using advanced centrifuges to enrich uranium in September 2019. Despite the numbers given by Tehran, the United Nations nuclear watchdog says Iran's real stockpile of enriched uranium now stands at over 3,241 kilograms, well over 16 times more than the limit laid down in that 2015 deal. Then in February this year, the United Nations nuclear watchdog discovered that Iran has started producing uranium metal, which is used in nuclear weapons. 2 months later, in April, both the German and Swedish intelligence agencies warned of growing efforts by the Islamic Republic to obtain nuclear weapons technology. In response, the oil-rich nation insists its nuclear program is for peaceful power generation only. A new study has confirmed that microplastics will continue to pollute the Earth's atmosphere for years to come. The findings, reported in the journal Nature, are based on models of the kind of impact airborne microplastics are likely to have on Earth's climate. Aerosols in the atmosphere can warm or cool a climate based on whether they absorb or scatter radiation. But this study is the first to calculate the global climate effects of airborne microplastics by using climate modelling. Microplastics were found to scatter radiation in the lower part of Earth's atmosphere, and that suggests they might have a minor cooling effect. However, the amount of plastic ending up in landfills and the environment is expected to double over the next 3 decades. So the authors warn that mismanaged plastic waste could have a strong impact on climate in the future and may already be playing a role in local atmospheric heating or cooling. Apple are progressing with development of their new 5G modem for their MacBook laptops. With the details, we're joined by technology editor Alex Zaharov-Reutt from ity.com.
Apple has always been trying to make its own technologies. We saw this most recently with its new M1 processors. But one of the things it's been trying to do for some time is work on its own 5G modems. Apple famously broke off with Qualcomm a couple of years ago. They had a big lawsuit against each other. Apple was relying upon Intel to make 5G modems, and Intel couldn't quite do it. So Apple ended up buying Intel's modem division for $1 billion and signed a deal with Qualcomm. And of course, now the 5G chip inside is a Qualcomm chip. But Apple doesn't like that. They like to have their own technologies, their own graphics, processing units, their own CPU. And they've done that with as many technologies as they can. And the next one off the rank is the 5G modem. So future Apple devices, including the Macs and the MacBooks, will come with Apple's own brand of 5G modem. You know, they will have that ready in the next couple of years, no doubt, and then they won't need Qualcomm anymore.
When I think of a modem, I think of a... This is different,
Sure.
I take it. This is a built-in modem inside the Mac.
Yeah, inside your iPad, inside your iPhone, and inside future Macs, there'll be a little modem which is basically a shrunken version of the modem that you have sitting powering your fiber optic or VDSL connection. And obviously it's just a chip on the motherboard with some supporting chips, and it connects to the antennas that are in the phone, tablet or computer, and it talks to the wireless signals that are in the air. Being able to own your own modem technology as well as your own CPU and graphics and other technologies means you don't have to pay a middleman. You don't have to pay royalties. One of the big things that Apple was annoyed at with Qualcomm at was that it was charging royalties to the original equipment manufacturers that were making Apple's technologies, and they were charging Apple as well. So they were accusing Qualcomm of double dipping, and Apple tried to do an end run around Qualcomm by partnering with Intel. But there was a problem where Intel's technology just wasn't as fast or as good as Qualcomm's. And in the end, Apple had to face reality and do the deal with Qualcomm again so that they could guarantee that the iPhone models would have 5G a year after competitors
Everyone
like
else,
Samsung
yeah.
had it. Yeah, but Apple was able to launch with second generation 5G modems that in the US at least could do both the millimeter wave and the regular 5G. And that can deliver extremely fast 5G, much faster than the traditional 5G, which is not a lot faster than 4G, as we've spoken about in the past with the dirty little secrets about how 5G really isn't that much faster than 4G. But millimeter wave 5G is much faster than that. But the problem is its range is very short. And even things like the glass on a window is enough to block that signal. So millimeter wave 5G requires a lot more infrastructure, more towers and more antennas, which will only spook the anti-5G people even further.
Meanwhile, isn't 6G where we're heading now? I mean, I know the European Space Agency are already looking at developing 6G hubs.
Sure, look, 6G is a good decade away. I mean,
Oh, really?
well, the transition, I mean, look, maybe it'll come sooner than that because humanity seems to speed up its technological delivery and manufacturing
It's
and
its own
adoption.
version of Moore's Law, I guess.
Yeah, but, you know, we had analog, then we had 1, which was 1G, then we had 2G, which was the first GSM phones, and we had 3G and 4G, and there's sort of been at least a decade between those developments. I mean, so it's 6G, yeah, they're talking about it now, and I mean, I remember talking about 6G before 5G when people were talking about 5G, and I used to ask them, well, what does 6G look like? And they would say, look, we don't want to talk about it yet, let's just get 5G on the table. Now that 5G's here, it's going to go through many evolutions, there'll be 5.5G, so we're going to see improvements to 5G, but 6G, well, I don't think it'll be like Star Trek teleportation yet, that might have to wait till 8 or 9G, but it's coming.
That's Alex Zaharov-Reutt from ity.com. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favorite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.